Hi everyone, in this video we are going to prove that y power set is equal to 2n, where n is number of elements in a set. Although there is no requirement of proving this formula if I talk about a competitive exam, but still some students have some curiosity why this formula is 2n only. So firstly, we are going to take an example and then also we will take the complete proof why it is 2n only. So in order to prove this particular thing, we require two important formulae, or we can say two important concepts. The first is from the binomial expression, and the formula for that will be x plus y whole power n. The formula is in front of you. You can just take a glance on this. N c power 0 xn plus nc1 x power n minus 1 into y, and so on. This formula we have taken from the binomial expression. The second formula that we are going to use is NCR formula. NCR formula is n factorial over n minus r factorial into r factorial, where we know that this formula stands for number of combination that can be possible. Okay, so before proving this particular thing, I will take an example and then we will take the proof as well. Okay, firstly, think that suppose we have a number of elements as 3. Let's suppose we have a set A containing the values like 5, 6, 7, and we have to figure out the power set of this. So for that power set, we have to form all the possible combination that can have. So the first, we can say that null element can be there. So you can write 5, 5 stands for null. The second, only one elements that can be possible, 5, 6, 7. Then 2 elements can be possible, 5, 6, 6, 7. And then we can say 7, 5. Again, the positions are not important because once I told you the combination concept, I told you that in combination, the arrangement is not important. Once we are doing the permutation thing, there the arrangement is necessary and it is the important. But if I talk about combination, so the positions are not that much important. So either you will write 7, 5 or you will write 5, 7. Both have the same meanings. Okay, so please don't confuse yourself like this. So null element, then we have one singlet element, then we have the doubles element, and then it can be possible that we have all the 3 elements in the same thing. So how many number of power set? So sorry, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. And if we use the formula 2 power n, that is equal to 2 power 3, because number of elements is 3. That is also equal to 8. But sir, why only 8 means how this particular thing has been formed? So you can just understand n stands for number of element, c, and let's suppose r you are taking. R stands for number of element you are taking at a particular time. So for an example, we are taking for the total number of elements is 3. So n is 3, c is 0. If you find the value of this by using NCR formula, you could able to figure it out. The value will become as 1. Similarly, NC1, the value will become as 3. Similarly, NC2, the value will be 3 again. And for 3C3, the value will be 1. If you add all of them, you will get 8 number of elements will be there. Or we can say the power set will be equal to 8. Or we can say the number of combination that can be possible, that will equal to 8. Okay. So here the power set, you can identify power set in a multiple stages. You can use this particular approach. You can use this particular formula. You can use this particular approach or concept as well. So again, there will be multiple ways by which we can prove that this is equal to 8. But our agenda is not to prove that the number of element will be 3, so it will be 8. Our agenda is to prove that particular formula. That is this one. For that, we can just use some of the concept. Just give me 1 second. Okay, absolutely fine. So what we can say that suppose we have n number of elements, right? N number of element. So can I say that in that case, what will happen? NC0 plus NC1 plus NC2 plus NC3 and plus so on up to NCN will be there, right? Okay, you can just take a glance on this. And if I use the formula of binomial expression x plus y whole power n, we know that this is equal to nc0 x0 y1, sorry, yn, or we can say this will be 1 and minus 1. You can take it anyway. This nc1, then it should be x2 yn minus 2, and similarly so on. So if we compare with this particular formula and this particular thing. So you could able to see that x will become as 1 and y also equal to 1. You can just compare both of them. If x and y both are 1, so can I say that this particular thing, what will happen? It will become 1 plus 1 whole power n, that is equal to 2 power n. So this is the entire proof of the power set. Power set basically tells us that how many different combinations can be assessed by that, but all the elements that can have. So we have to figure it out that if we are taking only one element, so how many possible combinations can have. If we are taking only two elements at a time, so how many combination can be possible. So this is the power set is trying to explain. So although in our exam, you can directly use the formula 2 power n. This is the entire proof. You can just take a glance on this and you could able to understand that it is always 2 power n. There will be no terms and condition because this is the entire proof, and in this entire proof, we hadn't taken any kind of we can say assumption. So that's why it's a formula that we can use all the times if you are asking the power set. So this is all about in this video. I hope you understand that why power set is equal to 2n only. Thank you.